All right, hi everyone. I've tried to make this as close to your note as possible without like making it exactly your note. So I've set things up so you're gonna learn to make equivalent systems today. I'm gonna show you how to make new equivalent systems. So the first one I said is solve by graphing, and I gave you a hint to rearrange into y equals mx plus b form. So rearrange this and rearrange this into y equals mx plus b form. Hey, supply teacher, press pause and give them 2 minutes to rearrange into y equals mx plus b. I'm going to do it quickly myself. So I move x over. Two y equals 10 minus x. I divide by 2, divide by 2, divide by 2. That y equals 5 minus x over 2. I rewrite into y equals mx plus b form. There's my first equation. Repeat for this one. Minus 4x minus 4x so if you have a y term, right, negative y term right here, you're going to want to make it a positive y because y equals mx plus b has a positive y term. So I can just flip all the signs if you want to just do that, or you can multiply everything by -1 and it'll all convert nicely to this. So I've multiplied every term by -1, or I've flipped every sign, and I'll just do a quick rewrite. Okay, so this one, my m is 4 over 1 and my b is 14. So I've got 14 right there, 0, 14. So it's hard with this. I go 1, 2, 3, 1, 2, 3, 4, 1, and that kind of gets me off the page. But I can also go backwards. I could go down 4, 1, 2, 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1, and you'll remember that a down and a left are two negatives, and a negative times a negative makes a positive, and that's why you're allowed to do this. 2, 3, 4 over 1. Okay, so that's a good amount of points, and I'll connect that with a ruler in a sec. This one I start at 5. And I have a negative slope, because this slope also is -1 over 2x plus 5. So I'm at here, I go down 1 over 2, down 1 over 2, but that's leading me away from my line. So I can go up 1 over 2, hey, up 1 over 2. So there's my 2. Take 1 minute and draw yourself your lines. I'm just going to put down my phone because I can't hold my phone and draw lines at the same time. So just give me 1 second. Awesome. The ruler I'm using isn't great, but I got my point of intersection right there. My point of intersection is at -2, 6 is my point of intersection. Awesome. Okay. So then after you get your point of intersection, or solve by graphing, I then ask you, and let me just go to my computer so I can do this. I ask you, and I'll try to just do this on another sheet of paper. I keep this one handy for after. I ask you to try adding your two equations. So if I have x plus 2y equals 10, that's your first equation, and you've got 4x minus y equals -14, and I ask you to add them. Well, you're just going to add like you learned your adding algorithm in elementary school. So what's 1 plus 4? That's 5x. What's 2 plus -1? 2 plus -1 is positive 1y. And 10 plus -14 is -4. Okay, good. Now we'll rearrange that into y equals mx plus b form. So we'll go minus 5x minus 5x. Y equals -4 minus 5x. Let's just rearrange this real quick so that way it looks like y equals -5x minus 4. So y equals mx plus b. My b is -4 and my m is -5 over 1. Oh, well, let's remember this and bring it right back over to our graph now. So our m was at -4. Let me just recheck our slope here. Down 5 over 1. Perfect. So I go down 5, 1, 2, 3, 4, 5 over 1. I can go up 5, 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. Will you look at that? It's the exact same point of intersection. Sorry if I kind of lost track there. It's hard to video and do at the same time. So gave us another point of intersection at negative 2, 6. That's when I added the two equations. Well, what if I subtract the two equations? So that's x, let's draw a line there. X plus 2y equals 10 minus 4x minus y equals negative 14. Okay, so what's 1 minus 4? And you have $1 and you spend $4, gets you negative 3x. 2 minus negative y, which when you take two negatives and you have them together, it turns into a plus. So that's really 2 plus 1, which will be plus 3y. Don't believe me, take your calculator, go 2 minus negative 1, and it gets you to 3y. And finally, 10 minus negative 14, or 10 plus 14, gets me to 24. Again, let's rearrange into y equals mx plus b form. I'll add 3x, add 3x, and now you have 3y equals 24 plus 3. Divide by 3, divide by 3, divide by 3. 24 divided by 3 is 8. 3 divided by 3 is 1, so I'll just write x, and I'll rewrite that, and y equals 8, x plus 8, there we go. And so my y-intercept is 8, and I go up 1 over 1. So my y-intercept is here at 8. Up 1 over 1, 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 and hey, let's backtrack. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And oh my goodness, it also goes through my point of intersection of negative 2, 6. Let me draw a line. Look at that amazingness, and I now have all my points of intersection drawn amazingly. Wow, that's amazing. Stay tuned for the next part in this great video. All right, in my next example, I tell you to solve by substitution. So when I look at my two equations, equation B looks like it'd be easier to solve for substitution because x is already by itself. So I'll take x minus 2y equals 7, and I'm going to isolate for x. So let's add 2y and add 2y. X equals 7 plus 2y. We have now successfully isolated for x. If I isolate using equation B, I must substitute into equation A. So I can't just reuse this into B, I must reuse this into A now. So I'm going to substitute this into A now. All right, so I take equation A of 2x plus 5y equals negative 4. I now substitute my x value, so I write 2, and you always substitute in using brackets. Awesome. I now use the distributive property. 2 times 7 is 14. 2 times 2 is positive 4y. And then I go 5y equals negative 4. Awesome. Next up, I think we can clean this up by combining these two like terms because they both have a y variable. So 4 plus 5 gets me to 9y equals negative 4. All right, let's isolate by moving this over. So subtract 14, subtract 14, 9y, yeah, negative 4 minus 14 gets me to negative 18, divide by 9, divide by 9, and y equals negative 2. Awesome. Now I'm going to take my negative 2 and substitute it into either equation. So you can pick either equation to work with. It doesn't matter which one you use. I'm going to substitute it into B because really it's a little bit easier looking to work with. So I'm going to substitute y equals negative 2 into B. You don't have to write that step, but I just like to do it so I know what I'm doing. So b is x minus 2y equals 7. And now I'm going to substitute that in. X minus 2 bracket negative 2 equals 7. Negative 2 times negative 2 gets me to positive 4 equals 7. Minus 4 minus 4. 7 minus 4 is 3. My POI, my point of intersection, is at 3 comma negative 2. And we got that because we knew y equals negative 2 and x equals 3. Awesome. So if you look in your sheet, I then said now multiply the second equation by 2. So I take the second equation. Here's equation 1. I say 2x plus 5y equals negative 4. I'll just draw a line down here so we can just keep things separate. Sorry. Equation A is still the same. Equation B, I say take the whole second equation and multiply it by 2. So I go 2 bracket x minus 2y equals 7. So I gotta do that times 2, that times 2, and that times 2. So it becomes 2, new b becomes 2x minus 4y equals 14, because I went 2 times x, 2 times negative 2, 2 times positive 7. All right, new b, original a. So I need to make new equations by adding, then subtracting. So let's do the adding first. So I got 2x plus 5y equals negative 4. I got 2x minus 4y equals 14, and I'm adding. 2 plus 2 is 4x. Positive 5 plus negative 4 gets me to 5 minus 4 is positive 1y. You got 4 and you add 14 gets you to positive 10. There's your first equation. Now, same move. 2x plus 5y equals negative 4. Where'd you get that from, Mr. Smith? Right here. 2x minus 4y equals 14. And remember it said subtract. All right. 2 minus 2. Oh boy. 2 minus 2 is 0. 5 minus 4 is y. Negative 4 minus 14 gets me to, oh boy, y equals, give me a second, I'm just kind of pausing here for a second to make sure I do this right. I got negative 4, I subtract 14 gets me to negative 18. Okay, good. So now let's solve by substitution, and look at that. You already have this here kind of isolated for you. Don't get confused if y equals 18. If I had my little Cartesian grid here, so there's my Cartesian grid, y equals negative 18 as a line tells you that all the y values are negative 18. So that means it's going to be a horizontal line through, not positive 18, negative 18. So that's negative 18 right there. And this line would be a horizontal line across at negative 18. And as I'm looking at that, I'm thinking I got the wrong number there. I'm just kind of looking at my math real quick just to double check to see if I made a mistake anywhere. So, oh, I see my mistake right here. A negative times a negative is a positive. So that'd be 5, that'd be 9y. Oof, there we go. Divide by 9, divide by 9. Don't you like it when you find your mistake? Negative 2, there we go. So that makes more sense. That's a horizontal line at negative 2. And that makes more sense because here it means that that can be a horizontal line through and have the same point of intersection. Okay, now I need to solve by substitution. So let's solve this equation solving by substitution. So first let's insert in y equals negative 2 and find out what our point of intersection is when I substitute that in. For x plus bracket negative 2 equals 10. Positive times a negative is a negative. Plus 2. Plus 2. 12 equals 4x divided by 4 divided by 4. x equals 3. Oh my goodness, where's your point of intersection at? X equals 3, y equals -2, which is the same as our point of intersection there, and you've done the exact same work by substitution.